I want to get on to how we're going to describe vegetation in the field. And we're going to do very similar to this. I want to get out into the field and I want you to think about strata. I want you to describe the strata in terms of height and cover. Using height, we'll be measuring using trigonometry, very simple measurements. And I want you to also to consider the cover. Now we've really been focusing on the canopy height, the canopy cover, but you could do that for any strata. There could be shrubs in the vegetation community and you could describe the height of the shrubs. You could describe how much of the landscape is covered by the shrubs. Again, projected foliage cover of the shrub layer, and you could do the same for the ground layer. Now, if I was going to describe vegetation fully, I would start with a physiognomy. I'd look at the physiognomy, how it actually looks, and I would add some floristics. So as soon as I say that this is a eucalypt woodland, I've actually combined a floristic approach and a physiognomy approach. I've said that it's a woodland. That tells me something, that it's got trees. It tells me that the trees are relatively widely spaced. But by adding the word eucalyptus, I've used some floristics there. So a combination of these approaches is quite good. And in the field, we're going to really focus on structure, but if you know something about the plants, even if they're common names, you should capture that information as well. Now, when we get out into the actual field, I want you to work in groups. We will be working in groups, I should say, and I want you to capture information to come up with a diagram something like this. Now, you could take a series of photographs to get this structural information. If we were doing a really scientific approach to vegetation sampling, there's a lot of things we'd have to consider. We'd have to consider things like, how do we put our quadrats, our sampling effort out into the field? You know, we'd want to randomize to be truly scientific. I'd have to consider things like replication. How many of these samples do I do out there? And I'd have to ask myself, how big a sample should I do? Obviously, if I was doing grasses, or a grassland, a small plot would be adequate. If I was dealing with giant trees, a small plot would obviously be inadequate. So there's a whole lot of things that we're not considering in this course. They are important about sampling vegetation, but we're going to take a pretty simple approach. So what I want you to do is go out there and then have a look at the vegetation and get representative measurements. How tall it is, how many layers are in the vegetation, and then what's in each of the layers. Are they shrubs? Are they grasses? Are they ferns? So that you can come up with a very nice labeled diagram. I'd just also like to introduce you to a really important way that we describe vegetation in Australia, and it's associated with a person, Ray Specht, R.L. Specht. And you know, it's often referred to as just the Specht scheme, but he first published this in 1970. And it's nice because we've been talking about physiognomy, and this is a physiognomic approach. Sorry, I'm stumbling over big words. It's describing vegetation communities on how they look, so they're actually structural formations. And so the Specht scheme is a way of describing vegetation, and it comes up with structural formations. And simple words that I'm sure you'll be familiar with, things like forest and woodland or shrubland or grassland are all structural formations. And in the Specht scheme, they all mean something. Now the Specht scheme it's super simple. It has an X and a Y, it's a table, and it just takes a couple of measurements and you end up somewhere in this table that tells you what you're dealing with. So let's have a look. The X is just a straight across percent foliage cover. The percent foliage cover, and I would just highlight it, all vegetation in the Specht scheme is classified on the basis of the uppermost strata, the canopy. It's the projected foliage cover across the x-axis of the highest strata. And there's a number of categories, and it depends on which type of Specht you're dealing with because it's been modified through time, but these are in categories. The y-axis is just life form. And the life form is simple. It's trees versus shrubs versus not. And the not things, you know, ferns or grasses or things that are like grasses. The trees are then divided up into height categories, so it's greater than 30 meters, 10 to 30, or less than 10 meters. So if I was going out into a vegetation community and it consisted of trees in the canopy, I need to know the height of that canopy, and I need to know how much of the ground is covered, the projected foliage cover of that canopy. And imagine I measured something, let's 50% cover, so half of the sky is covered, half is not, and I was dealing with trees 10 to 30 meters, I would fall into this very category, yeah? And that category, I don't know what it's called. That category is called an open forest. It's called an open forest. So spec scheme is really simple. Simple measurements. What's the dominant life form, how tall it is, how much of the ground is covered, and you fall into a particular category. That means I could go up to someone who knows spec scheme and I could say, I've been working in a eucalypt forest. No, that wouldn't work. I could say I've been working in an open forest, and they would have a clear idea what I'm dealing with. They would have a clear idea that I had trees in my vegetation plot, that it was a particular height and a particular cover. So like all classification schemes, it allows communication, and we can start talking about things and other people will understand what you're talking about. As I mentioned, if I went out into the field and I measured a tree-dominated vegetation community and the trees were between 10 and 30 meters and the projected foliage cover was between 50 and 30%, then that falls into this category, and that category in SPECT is called an open forest. Now let's just quickly have a look at shrubs, because shrubs also have different categories on the basis of height, but in the SPECT scheme they talk about sclerophyll, sclerophyll versus non-sclerophyll shrubs. And sclerophyll is, you know, it's an amazing thing because in Australia's vegetation we have an amazing diversity of sclerophylls. And sclerophyll just means hard leaves. You know, it's the kind of vegetation you wouldn't want to crawl through with good clothes on because you'd get tears and stuff. And if you think about some vegetation communities, nice and soft, whereas Australia is kind of dominated by a whole lot of scratchy things. Now, scleromorphy has got a number of characteristics. Hard leaves, short internodes, reduced leaves, a whole lot of things which in the Australian vegetation are associated with low nutrients. As the world went through the last 65 million years ago, the whole world started to get cooler and drier, and that gave an advantage to the sclerophyll vegetation in Australia. So you may have, you know, in high school, your teachers might have talked about things like sclerophyll forests. Notice that when you have a look at SPECT, have a careful look at the different categories, because there's things that you might expect in there that aren't in there. There's nothing called rainforest in SPECT scheme, for example. The highest density, if you like, protected foliage cover in the SPECT scheme is something called closed forest. So there's no rainforest. There's no mention of sclerophyll here, but it does happen at the shrub level. It's well worth having a look at SPECT scheme very closely because it's something that you'll use over and over again during your time at university.